Okay. Hi everybody. So we a few days ago designed how the broadcast mode would work for client-side tracking, which is a special mode where keys are not remembered server-side, but instead clients just register to prefixes, and every key which is touched about such prefix is sent as an invalidation message to the client. So it's a trade-off between a number of messages and state required to take in the server side. So we have this radix tree of radix trees, where the top level is the number of the prefix, with the empty prefix being the default prefix that will match with everything. And this is the structure that we have as a value of the radix tree, which accumulates the keys and all the clients subscribed to this state here. And yeah, we need to take here the client's pointers, not just the client ID, as we have now in the client-side caching implementation without broadcast, because we want to be able to immediately remove the client when in the case the client disables the client-side caching. Or, well, actually the alternative is that we have just a list of IDs here. It is also possible, because when we scan the list of IDs later, when we return to the event loop and we want to send the replies to the clients with the invalidation notifications, it is possible for us to check if a given ID has or not is or not associated with a client that has still the prefix enabled, but it's too much work and it's useless CPU time burn. So the problem with having a list of clients is that we have to remove the client from here every time the client disconnects or whatever. But we have a trick that we can use, that we use and this is a list, right? So removing from a list is slow. So we have two options here. One option is to just add, don't use a list, but use a radix tree as well, in order to add the client's pointers directly in the radix tree. So this will become rax clients. This could be a nice idea, actually. And another possibility is, of course, to use a dict, but we avoid using dictionaries because, in general, the rax iterator is good and uses less memory, and in general, in the average case, is more efficient and faster. It depends on the use case, but in general, it's better. Otherwise, if we use a list and we want to remove from the list in O1 instead of ON needed, if we would scan the list, we can just save the list node pointer of every list where the client is into. So for each prefix registered here, you see here, prefix, for each we register in the client structure a list of client node pointers. So we can remove in node one each reference. And this could be also a nice design. Yeah, probably it's a better design because it could be faster to remove and add the clients in this case compared to the lookup in the Redis tree. And also it's a bit clear, more clear compared to the idea of registering the pointer as the key. Even if it works, we do this in other places, but could be a more gentle design. Before we continue with this plan that we have, remember that here the invalidation message could contain multiple keys, but right now we have just a single key. So if I execute make sure that this is the right version that we are compiling. Oh my god, it's so slow, this computer. It's 2015. However, in order to upgrade, I'm waiting for the new line of MacBook with the new keyboard, so I'm stuck with this very slow computer. But you know, we are hackers, no? So no need for the shiny stuff. Just writing code, it should be enough. Just kidding. Okay, right now let's switch in RESP3 new protocol mode, so it's everything in the same connection. Okay, we enable client tracking, then we get a few keys, and then we invalidate in another connection some key by changing it, and our client receives the invalidation message, invalidate A. However, this A is a single value. Instead, we want here the ability to have an array, not just a single key. So we can start by modifying the current implementation to output an array. We perform these changes directly in the client-side caching 2 branch, which is the one that we, a few sessions ago, or the last session actually, converted from the caching slots from the key names. So directly do the work in the new thing. Even if this work is a bit orthogonal compared to the other implementation, they are actually two. It looks like it's a sub feature of client-side caching, but broadcasting has a different implementation because it's a quite different paradigm. So we send invalidation messages here. Okay, this is where we send invalidation messages. So in the old implementation, in order to have basically an implementation that replies always the same stuff, it's a good idea if we reply an array with a single key also here, and maybe also this will open for further improvements in the future, where we are able to maybe group multiple keys and send a single invalidation message also for the normal mode, not for the broadcasting mode. Here it's very easy because we just need to add reply array len, and it's always one. For the pub sub message, the thing is much more complex because right now the pub sub message does not allow to have an array as subtype. this is the function, and as you can see, what happens is that yeah, basically we reply a bulk channel and bulk message. That's it. This is how messages are sent in the PubSub channel. However, it is not technically a violation of the protocol if instead of the bulk as a message we send an array message. And yeah, it's not a violation, but clients are not prepared to do that. However, we do this only in the scope of a new feature. So old clients will support the old features without problems, and new clients will have, if they are not, a good client probably supports this out of the box because should not check if the second is a bulk or not. But there are a lot of client authors that put assertions inside the code about conditions that are not really needed to be checked, but there are many clients. So a few will break, but the change will be pretty trivial to fix. So what we do here, we want to reply with this thing and then send an array. Given that we are doing this right now as a very special case, no, it's actually already in two places. So let's create a new function. Okay, no, I changed my mind. This is a good case to show how it is possible to simplify the code. So I was creating a new function that will just do this, but not this, just without that. It doesn't make sense to create a new function. Because I wanted to do that because I didn't want to make this interface more complex, but actually we can do just if message. Otherwise, and we just change the top comment. So send a PubSub message of the type message to the client. Normally, message is a Redis object containing the string to send us message. However, if the caller sets message as null, it will be able to send a special message later by using the add reply API family. Makes sense. Normally message is a Redis object containing the string to send us a message. However, if the caller sets message to it will be able to send a special message by using the add reply API family. Okay, so with just 1, 2, 3, 4, 5, 6, 7, 9, 8 bytes change, we have the ability to still use the same API with the same prototype and everything the same. So how do we change this here? We no longer send the key object, but we send null, and we later do add reply len c1 and add reply bulk key object. It compiles. Now let's check if, okay, we can do a nice test here. Let's check if the implementation actually works with a client implementation that already exists, that is Redis CLI, which uses Redis. So what's the name of the channel? It is one. Okay. Client ID. This is ID 6. Subscribe to the invalidation messages. In another client, we enable tracking on, redirect to the client 6. Okay, get A, get B, get C. Okay, now even in the same client, let's violate this. Well, we didn't receive an array because maybe I forgot to restart the server. Yeah, I think so. Okay, let's do everything again. It's 4 this time. Okay. Okay, now it works. As you can see, this is the message, pub/sub type message, channel Redis invalidate. And this time we have the third element, which is an array. As you can see, Redis was not intended to work in this case, but works as expected as a side effect of being general enough. Okay, that's good. So, this is a good moment for a commit. Tracking. Okay. This violates the protocol that we documented for Redis 6 beta. We have only this possibility to change things now, and it's better to improve things, modify the documentation. And yeah, it's unfortunate, but no better options. Okay. Now, the second step is what we do in order to enable the tracking, because right now there is no broadcasting option at all. We have just enable tracking, client C, redirect to, and in order to support these advanced options, probably we want to move the parsing of the feature here, or we want to pass to redirect to, and we need to take as argument BCAST or the prefixes directly, and if it's not null, it means BCAST. No, let's be more explicit. Let's check like this. Maybe this is not the right way, but prefixes prefix. It's not grammatically correct, but it is short. Prefix 0, prefix 1, it makes sense anyway. Non-prefix. Okay, we could do things like that, but let's check if it is good enough, because this will force us in the client command implementation to do more parsing, more work. Probably it's worth it anyway. So if argument is 5, redirect and so forth. Okay. To start, we need to make this a bit more complex. Yeah, we need to. So, we have to start from here. If argc is greater or more than 3, it is fine with us. And the command fingerprint changes to client tracking on off, redirect ID, BCAST, prefix, and we can have multiple prefixes, so okay. We have multiple prefixes, so redirect is here, and also we want in BCAST mode if it is or not enabled, and then we want prefix num prefix, which starts with 0. Okay. We require the client with a specific date to X now. Okay, this we have to move here. Okay. So the first option is 0, 1, 2, 3. Okay. Int more args. This will be the number of arguments that are more other than the current one. Okay. If argv j redirect, and more args, j plus 1, blah 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 blah. Okay. Else syntax we can do here, what we can do here, yeah, just a generic syntax error should be enough. People to debug what's the problem. Okay. Else if after we do this, we need to increment j because actually we should do this here, so that we just write j here because we are consuming the next argument needed for the redirection ID. This BCAST will just enable BCAST, and we will pass it as a prefix. And by the way, in the design notes that are here, we said broadcast, but BCAST, everybody will understand BCAST, which means broadcast because of networking and if conving and whatever, so let's go shorter. Okay. If it's on, we enable tracking. If it is no disable tracking, okay, without options. The cleanup can be generic. Enable tracking, BCAST, prefix, num prefix. Okay. What about prefix? And there are more arguments. We need to do this prefix equal, reallocate it for enough RAM. Okay, this is an array of pointers. So realloc num prefix. Okay, realloc size of array object per num prefix plus 1. So make space, make room for another one. Prefix of num prefix equal argv j, which we increment here in order to seek the actual prefix. And then we can finally increment. Okay, let's do that. You know, I don't like smart code, but this is C101, so should be okay. And this is what we do here. Okay, enable tracking or disable tracking, whatever, triple I, but we need to do the cleanup. Okay, when we exit from this loop, if we have no BCAST, but we have prefixes, we say to the user, what's happening here? There is something wrong, for sure. So okay, this makes sense. And okay, this makes sense, I guess, so far. We changed this here. Yeah, looks like this is the most sensible design because we didn't made the client command much complex, and it's nice that enable tracking, which is the internals of tracking.c, is not responsible for syntax parsing, but it will just get, oh, here there was an error, prefix should be a pointer of pointers. Okay, we get this already clean, preparsed, sanity checked, so if BCAST is enabled, then prefix should be okay, but can be empty. can be 0 in case of, in that case we will subscribe it to the empty prefix. Okay, so we want to enable tracking anyway. If it is already enabled, and the user is just adding a new prefix, we should support this or not to call again. Yeah, it looks useful. Well, yeah, it looks useful because in this way the existing connection, if there is to add a new prefix, doesn't need to be closed. And yeah, the redirection can be again the same, maybe, or it could change. Also, okay, this was a problem before as well, because yeah, because if I would reassign the redirection to another client, it will silently say okay, but it will not work as expected. This is what I mean. So I start the server. Okay, so I do that, and I do this. Okay, it works as expected. Then I do client side, client tracking, on redirect 5. It says okay, but then I get A, get B. Oh no, it is actually, oh no, sorry. I increment A and I'm getting still the invalidation messages in the wrong channel because it was already broken basically here. So even if client tracking is already enabled, I continue here and I set a new redirection. Okay, but I increment the number of tracking clients only if this is not set. And okay, if the tracking table is null, it's okay for me. And if there are new prefixes, if the client was in BCAST mode and now it is no longer in BCAST mode, yeah, that's kind of tricky. We need to perform the cleanup. Also to switch to BCAST. Yeah, we may want to throw an error in that case. However, if it is just a matter of adding new BCASTs, we can handle that. So maybe here we could do that. Okay, so if client tracking broken redirect and client BCAST. Okay. So here we check this: if client flags and client BCAST and in general, if client tracking okay, just if client tracking old BCAST equal client flags and client tracking BCAST, but in this case we get the value of the flag position, and we want this to be 0 or 1, so we normalize here with this trick of the double note. The first note will change it from if it is a positive number to 0, and then from 0 to 1, or the other side around. Okay, if old BCAST not equal BCAST, so if we change the BCAST state, we get an error here. And okay, this is fair, I guess. Okay. Now we are here, and we want to enable tracking for this mode. So if the table and so forth and so forth, we can already assume here that if the client was already in tracking mode and BCAST was active, then we can add more prefixes and the mode is not changing. Okay, so okay, first thing to do before even changing this one, tracking remember key. Who calls this? This is called here. Okay. So we want to remember the keys for this client only if it doesn't have client tracking enabled. Only if it has client tracking enabled, but not in broadcast mode. Otherwise, we don't want to enter this code path at all. Okay. What we do here instead, Okay. If we don't have any prefix, we enable broadcast tracking for the empty prefix. In general, we loop Okay, so broadcast will just add and probably we want to do that to enable all the prefixes only if the client was not already in prefix mode. No, it's too complex semantics. We will write just that if prefix is not specified but BCAST is, simply what happens is that you enable everything, all the empty string prefix. In theory, we should do the cleanup of the other prefixes because it doesn't make any sense to have this one and don't have and have other prefixes, and you will receive duplicated notifications. But this is up to the client to avoid doing very stupid things. Okay, but here we want to do that. Client tracking BCAST. Okay. So we enable this, we enable BCAST tracking. Now let's check our design document. It's just a small page, but it is useful. Okay, we lack all these data structures here. We don't have in the client the list of p-tracking of bcasting prefixes and so forth. In the course of the current event loop, for every key access we get that changes the variable is populated above Redis. Okay, so we don't have still this function here, but we better go with the main data structures to start. So we have a tracking table, but we also need a prefix table. And when we allocate our tracking table, we also allocate our prefix table. Tracking table is just our sentinel, but we allocate all the other stuff here because it's all or nothing. So we allocated this prefix table here, and that's very simple. But we also go to the client structure. And here we want to have a list of prefix nodes in order to remove and add in a very fast way, in order to remove all the existing prefixes. Our client from all the existing prefixes. Okay. Client, what it was called? Prefix nodes. Okay, we start with null, and when we free the client, we will handle that. Okay, let's put this in our to-do list. Okay. Okay, so far so good. I'll do another session with continuing with this design later today, I guess. Lunchtime now. Thanks for watching. Bye.